Welcome, my name is Dr. DrWedding, and this is DrWedding, DC04. Voltage, current, resistance, and Ohm's law. Many people hear the words voltage, current, and resistance, but do not really have a good understanding of what these words really mean. This video will give you a solid understanding of voltage, current, and resistance. Once you understand what these words mean, Ohm's law will be introduced. Because you can't see or touch voltage, current, and resistance, these terms need to be described in a way that is familiar to most people. There are many different analogies that can be used to help explain these concepts. And no analogy is perfect, but I have found that this explanation is very good when explaining this concept for the first time. Think of voltage like a bucket of water that is stored on a shelf. The water is not moving. If you were to use a measuring tape, you could see how high this bucket of water is off of the floor. Think of the distance from the floor to the bucket as the voltage. In this example, think of this as 6 volts, because the bucket is 6 feet off the floor. Because nothing is moving, voltage can be thought of as potential energy. Note: volts are the unit of measurement for voltage. If you drilled a small hole in the bucket, water would start to flow out. Think of water leaking out of the bucket as current. It should be easy to remember because current is the same term that is used to describe water moving in a river. If you think of voltage as potential energy, then current is like kinetic energy. Note: amperes, or just amps, are the unit of measurement for current. Think of resistance as the size of the hole that was drilled into your bucket of water. A small hole has a lot of resistance, so only a little water can escape. And a large hole has very little resistance, so a lot of water can escape. Note: ohms are the unit of measurement for resistance. It is written as an omega. So a large resistance will cause less water to flow, and a small resistance will cause more water to flow. If this explanation makes sense to you, the next step is to understand how it relates to the way a circuit works. Below is a 50 ohm resistor. On the right side of the resistor, you can see the voltage. The voltage has a plus sign at the top of the resistor. Think of the plus side as the shelf holding the bucket of water. The voltage also has a minus sign at the bottom of the resistor. Think of the minus sign as the floor that is below the shelf. When a hole was drilled into the bucket, water starts to leak out and fall from the high shelf to the low floor. On the left, you can see the arrows that point in the direction of current flow. So current will enter the resistor on the high side and exit the resistor on the low side, just like water falls from the high shelf to the floor. Ohm's law describes how voltage, current, and resistance are interrelated. The equation is V equals IR, where V is the voltage drop in volts, I is the current flowing through the resistor in amps, and R is the value of the resistor in ohms. This equation is extremely important, and you need to memorize it. You may have seen this triangle in a book or on the internet. It is used to help you isolate a variable. If you have had basic algebra, then you know how to get one variable on the left side of the equal sign and the other two variables on the right side of the equal sign. In that case, this triangle is useless to you. However, if you do not know how to isolate a variable, this triangle may be of some help. To use the triangle, you first draw it on your paper next to the problem. Then you put your thumb over the value you are looking for. If you want voltage, cover the V. This tells you that V is equal to I times R. If you want current, cover the I. This tells you that I is equal to V divided by R. Finally, if you want resistance, cover the R. This tells you that R is equal to V divided by I. Here is an example. What is the voltage across a 50 ohm resistor when 0.2 amps is flowing through it? Start by writing the equation V equals I times R. Next, you plug in the known values. Make sure that the current is in amps and the resistance is in ohms. You then isolate the variable that you are solving for. If you have trouble solving for the unknown variable, you can use the triangle. The triangle is drawn on the page and the V is covered because that is what we are looking for. Now you know that the answer is I times R. 0.2 amps times 50 ohms is equal to 10 volts. Here is another example. What is the current through a 200 ohm resistor when 6 volts is across it? Start by writing the equation V equals I times R. Next, you plug in the known values. Make sure that the voltage is in volts and the resistance is in ohms. You then isolate the variable that you are solving for. If you have trouble solving for the unknown variable, you can use the triangle. The triangle is drawn on the page and the I is covered because that is what we are looking for. Now you know that the answer is V divided by R. Rewrite the equation as I equals V divided by R. 6 volts divided by 200 ohms is 0.03 amps. Going back to the video on numbering systems, 0.03 amps is the same as 30 milliamps. Here is the final example. What is the resistance if the resistor has 25 milliamps through it and 10 volts across it? Start by writing the equation V equals I times R. Next, you plug in the known values. Make sure that the voltage is in volts and the current is in amps. 25 milliamps is 0.025 amps. You then isolate the variable that you are solving for. If you have trouble solving for the unknown variable, you can use the triangle. The triangle is drawn on the page and the R is covered because that is what we are looking for. Now you know that the answer is V divided by I. Rewrite the equation as R equals V divided by I. 10 volts divided by 0.025 amps is 400 ohms. For practice, you should pause the video and find the missing value in each row. The values are already in volts, amps, and ohms. After you are done, restart the video to check your answers. Here are the solutions. Converting to volts, ohms, and amps gets annoying, and it can also lead to mistakes. Using metric notation is a lot easier. Just keep a few things in mind. A kilo times a milli equals 1. When you divide by a kilo, you get a milli. And when you divide by a milli, you get a kilo. These rules can be applied to the other metric notation prefixes. You just need to remember the mega and micro work together because they are both 10 to the power of 6. And giga and nano work together because they are both 10 to the power of 9. In this example, the currents are in milliamps and the resistances are in kilo ohms. In the first row, you are looking for the current, I. I is equal to V divided by R. If you keep the resistance in kilo ohms, your answer will be in milliamps. The magnitude is 15 divided by 1. So the answer is 15. The units are in milliamps because you divided by a kilo. So the answer is 15 milliamps. In the second row, you are looking for the voltage V. V is equal to I times R. Keep the resistance in kilo ohms and current in milliamps. The magnitude is calculated by multiplying 5 times 0.22. So the magnitude is 1.1. The units are in volts because a milli times a kilo is 1 and an amp times an ohm is a volt. So the answer is 1.1 volts. For practice, you should pause the video and find the missing value in each row. After you are done, Restart the video to check your answers. Here are the solutions. This video should have helped you understand what voltage is, what current is, and what resistance is. You should also be able to use Ohm's law to find a missing value when you have the other two values. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.